Alright, this is the second video on doing the product and quotient rule. So this is on the quotient rule, and if I have two functions that have a derivative at an x, and as long as the g of x is not 0, then I can go ahead and take the derivative, and the derivative of the quotient is derivative of the bottom times the it's the bottom function times the derivative of the top minus the top function times the derivative of the bottom over the bottom squared, or we say low d high minus high d low. If we want to stick with that, if we have a over b, it's going to be b a prime minus a b prime over b squared. Or if we want to stick with the ABA that we used for the product rule, it's a prime b minus b prime a over b squared, and I think that's probably what we're going to use. We're going to use ABA. So it's the same thing. You got instead of a plus, it's a minus sign, and then you got a b squared in the denominator, and so we're going to set things up a lot like that. So we derived the derivative of sine and cosine earlier. So derivative of sine is cosine. Derivative of cosine is minus sine. So we're going to use that to get the derivative of the tangent, the cotangent, the cosecant, and the secant. So what I think I'm going to do is I'll narrate through maybe the derivative of tangent and the cosecant. And I have it worked out for the cotangent and the secant, but I'm not going to narrate it to save time in the video here. So if we look at finding the derivative of the tangent, we can write tangent as sine over cosine. Okay, so derivative of the tangent can be written as the sine over the cosine, and we'll go ahead and mention we'll use the ABA form. So a prime b minus b prime a all over b squared. Identifier a prime, b, and b prime. Okay, I'm going to install that in, and then I'm going to make a mention here that if I have sine squared plus cosine squared, that's one of your Pythagorean identity, that's equal to 1, or if you have cosine squared plus sine squared, that's going to be equal to 1. So we're going to use that in a minute here. So f prime is going to be a prime b minus b prime a, and then that's going to be all over b squared, and so we're going to get cosine squared plus sine squared x over cosine squared, and cosine squared plus sine squared is 1, so we have 1 over cosine squared, which is equal to the secant squared. So that's something that you're going to want to know, so maybe you make yourself some flashcards for the derivatives of the 6 trig functions. Okay. On the next one, we're going to do the cotangent. I'll pause it for a moment to give you an opportunity to pause it and let you work it out, but I'm not going to narrate it. It's basically the same thing. Okay. So there's the cotangent. I'll give you an opportunity to pause. So it's the cosine over the sine. So if you need to pause the video, you want to try it out on your own, you're welcome to. And then I'm gonna go through it. Okay. So you see at the very end, we're going to get derivative of cotan is cosecant, negative cosecant squared. So the whole process is there. Now what I think I'll do is we'll do the derivative of the cosecant, and then I'll leave the derivative of secant to you. It's on the video. I'm not going to narrate it though. So if we're going to look at the derivative of the cosecant, that's going to be 1 over sine. So we'll just write ABA off to the side here. Okay, so a over b prime is a prime b minus b prime a over b squared. So a is 1. A prime is 0, b is sine, b prime is cosine. So we'll put that in and take the derivative. We have 0 times sine minus cosine times 1 all over sine of x squared, and we're going to write this as minus 1 over sine x minus 1 over sine x times cosine x over sine. So we'll still have the minus cosine and then the sine squared on the bottom, but we're writing it this way so that we get the minus cosecant x and cotangent x. Okay, so that's another derivative rule that you'll want to know, is derivative of the cosecant. On the next slide here is secant, and secant is 1 over the cosine. Okay, so I'm going to pause it right now. If you need the opportunity to try it out on your own, I would encourage you to. You have that opportunity. Alright, and all the way through, and derivative of secant is secant x tangent x. If you want to say tangent secant, the order doesn't matter, but I think typically how I say it is secant tan, and how it is in your textbook is that also. Okay, we're going to run through a couple more examples. Just following this same process, so if you want to pause the video and try it out on your own, I would very much encourage you to do that, and if you get stuck, then you can refer to the video. So here we're going to look at something pretty ordinary, 2x over x squared minus 9. We'll identify what the a is, a prime, b prime, and we'll go through the process. There might be a little bit of algebra to do at the end. So a is 2x, a prime is 2, b is x squared minus 9, b prime is 2x. So f prime of x will be a prime b minus b prime a all over b squared, and we'll go ahead and work that out. So we have 2x squared minus 18 minus 4x squared all over the denominator. Typically we want to leave the denominator alone, and we arrive at minus 2x squared plus 18 x squared minus 9 squared. And actually I have the minus on the outside, so that applies to both the 2x squared and 18, which will turn them negative. Okay, so pretty basic. We'll go through maybe a slightly harder problem. So same process. This one will have a little bit of fractions, and we get to say we've done that. So 3x plus 2 over the square root of x. We'll go ahead and write the derivative rule off to the side again. So a is 3x plus 2. A prime is 3, b is x to the 1/2, b prime will be 1/2 x to the minus 1/2 using your power rule. So f prime of x will be a prime b minus b prime a, and then all over b squared. Okay, now it's going to get a little tricky here because I'm going to factor out a 1/2. Okay, factor out a 1/2 out of the top. So we're going to take the 3 and divide it by 1/2. That's going to give me a 6. And we're going to, oops, I said 1/2, right? Well, I meant 1/2. Alright, and that's going to give me a 6, and then the 1/2s will cancel there. Okay. And then we'll factor out an x to the minus 1/2 because that's the smallest exponent. So it's minus a negative 1/2 minus a negative 1/2. So that makes that an exponent of 0. So all of this stuff is going to end up going away of how we factor it. This will end up being an exponent of 1. Okay. So let's go ahead and take care of that. Okay, so take out that 1/2 x to the minus 1/2, and we have 6x minus, and distribute the negative sign, 3x minus 2. X to the 1/2 squared, remember that's the square root of x squared, which is just x. We're going to go ahead and take this, move that down. This will also move down, but when it moves down it becomes positive, so it'll be x to the 1 plus 1/2, which is 1 1/2, or also known as 3/2. Okay, so that's going to come on down. So let's get all that stuff out of the way. Alright, so 2x to the 3/2 on the bottom, and then we have 3x minus 2 on the numerator, and that is it. Okay. Alright, the next example we're going to look at might look a little scary, but we're going to simplify it down so it's not so bad. So we're not doing a quotient rule within a quotient rule. So we got what's called a complex fraction or compound fraction, where you have a fraction in the numerator or the denominator, or possibly both. We just have a fraction in the numerator here. It only has one denominator, and that's an x. So we're going to multiply the top and the bottom of the big fraction by x, and that'll give us 3x minus 6 over x cubed. And now that's going to be much more, it'll make it a lot easier to deal with. I was going to say it's going to be a nicer looking problem, but I don't know if problems are going to look nice or not. A is 3x, a prime is 3, b is x cubed, b prime is 3x squared. So we'll go ahead and install it. So we have a prime b minus b prime a all over b squared. So we got 3x cubed minus 9x cubed plus 18x squared all over x to the 6. Okay, this is going to make a minus 6x cubed and a plus 18x squared. So we're going to be able to factor out a 6. I'm going to factor out a negative 6 and an x squared. What that'll do is we'll be left with an x and then a minus 3 all over x to the 6th, and then we can go ahead and reduce this down to an x to the 4th in the denominator. So yeah, minus 6 x minus 3 all over x to the 4th, and that's about it. Okay, we'll take a look at one more. It's a little messy, but the process is the same. Identify your a prime, b, and b prime. So we have the sine of x minus x squared over cosine of x plus 2x. Okay, so a is sine of x minus x squared, a prime is cosine x minus 2x, b is cosine x plus 2x, and the b prime is equal to minus sine x plus 2. Okay, so f prime of x is equal to a prime times b minus b prime times a all over a squared. And we can FOIL it out, so that's a difference of squares. Cosine squared x minus 4x squared plus sine squared x minus x squared sine x minus 2 sine x and then plus 2x squared, and then all over cosine x plus 2x quantity squared. Okay, there might be a little bit you can do. We're getting kind of lengthy on the video here. So the cosine squared and the sine squared, that's going to be 1. So you'd have a 1 there. You got a like term here and here. So that'll be a minus 2x squared. And then what do we got left? We got this stuff with the signs. So we could factor out a minus sine of x, and we'd have x squared plus 2. And that would all be over that denominator there. So there might be something to do there, but we're getting pretty lengthy, so I'm going to stop it there.